Yeah. Literally, I just was really mad and I went to down so good. I don't know what happened.
All right.
Did you
Hey,
see
Charger.
I
hate
Charger. I will see if there are any back there.
Hey, can you look for me too?
You're right there.
No,
I can see you. I don't need to look for you. You're right there.
A charger.
Charger. Okay. Let me see.
I hate it.
That's 3.
Me too.
That's 4.
I wish
That's
my
five.
better teacher.
Pushing your luck.
Okay, Mr.
Huh?
I don't know, wait, what's the thing, Mr. Brand? Wait, no, Brand. Yeah.
Oh, yeah.
God.
It's not gone, I just can't use
Hey,
it.
make it fucking so I keep on oh.
Here you go.
Oh my god.
That's all that I have.
Thank you. So far, we're not talking about
Sorry.
Yeah, it's so easy. Because Mr. Michael was like, oh, we want you guys to be really loud.
Bro, we could buy the
So we are.
jacket, volleyball jackets.
Okay. Today, ladies and gentlemen, we're going to start talking about density lab. Actually, you'll start doing the density lab. That's going to be due tomorrow. So we're going to be able to find the density. Hey! I didn't spring a leak. That was me asking you to be quiet. Sign in, please. And then we'll have you go finish up so you can grab your stuff again. All right. Today you are going to be doing a density lab. Okay? So you're going to find the density of various objects by graphing them. So that is why we were doing the graphing part first. But before we do the graphing part first, my question of the day today for you, ladies and gentlemen, is how do we find the density of an object? Jake, go for it.
Do we get its dimensions and its weight?
Okay.
And then we divide the weight by its dimensions.
Okay. You are using some not scientific terms. I don't like the term weight because it makes me feel like I can't do something right away.
Mass.
Okay, mass is much better. Okay. How will we find the mass of an object?
We'll put it on the balance.
We will put it on a balance that we have out in the back that are all ready to go for you. Perfect. Okay. Now, what exactly is volume? Don't everyone jump on this all at once. Take your time. Think about it for a second. What is volume? Lola.
Length times width times height.
It is if your object happens to be of what shape?
Oh, a rectangle.
A square, rectangular, cube, something like that. Are you ready? There you go. So, absolutely, that is the way we would find the volume of a square, a rectangle, a cube, a shape along those lines. Definitely. But what exactly is volume? What is the definition of volume?
The space an object takes up.
The amount of space an object takes up. And you are absolutely correct. If we were doing something like the tabletop up here, we could measure its length, its width, its thickness, we could find its volume. Okay? That could be a mathematical formula. So, Jake, I believe you mentioned that somewhere at the start we could measure the dimensions of something. We could. Problem is, well, sometimes you get things that aren't shaped like a cube. You get things that are shaped like a cylinder. Or maybe you get something that's shaped like a sphere. Or maybe you get something that is shaped like a triangle. If you get those things, ladies and gentlemen, you need a different what each time?
Formula.
And I don't happen to know all the formulas off the top of my head. Okay? Now, there are other ways of doing it, though. In science, you have probably found the volume of an object another way. Can someone tell me the other way we could find the volume of an object in science? And whatever you do, don't look at my desk for hints. Shh! Use one word and stop.
Is it called? You can use the hydro. Is it called hydro flask?
The what's that?
Hydro flask.
Hydro. Where do you see a hydro flask?
Okay. What they're called? The
Okay.
test tubes.
graduated cylinders. You're on the right track. Well, look.
You like put it in water and see how much water like goes in it.
Okay. Anybody know what that method is called?
Water displacement.
Volume by displacement or water displacement. Now, it is very important that you do these steps in a certain order, ladies and gentlemen. Can someone explain to me the steps that we do for water displacement?
Put it in the water.
Put what in the water?
Put the wait. So first, look at how much water is in the whatever you're putting it in,
Okay.
and then you grab the object and you put the object in the water,
Okay.
and then you see like how much water
Good.
is.
Good. So you guys have done this before. So I have two graduated cylinders here, ladies and gentlemen. Okay? Two graduated cylinders here. Natalie, what place does that graduated cylinder read to, Michelle? What place does that one read to? By place, I mean tens, ones, tenths. This reads to the ones. That is 10, but are there any marks between like 30 and 40? How many? Enough to find the ones place? So both of these two cylinders, both read to the ones place. So which one should I use? Nope, we're not going to talk about accuracy. Precision. Both have the exact same precision. Does it matter which one I use? In reality, no, it does not. They both have the same precision. Now, another factor is sometimes one of the object.
What?
The size of the object. This is a much smaller graduated cylinder than this one, correct?
Mm-hmm.
But can I fit these objects in here? The answer is yes, I can. Okay? So I still would probably prefer to use this graduated cylinder rather than this one. Parker, when you look at these two graduated cylinders that are both reading to the ones place, do you notice any reason why I would maybe rather use this one than this one? They're both to the ones, same precision. But I would prefer using this one over this one. Any idea why? Okay, it's smaller. Okay, that is a good guess, but it wasn't what I was looking for. But thank you, Alia. The ticks are bigger. What do you mean by bigger?
Easier to see, 'cause, like some people have trouble seeing.
Why are they easier to see on here than on here? They're both marked out in white. You're on the right track, though. You don't. What are smaller?
This one's smaller.
The what is smaller?
This.
The whole thing?
Yeah.
Okay, so we said that. We said that. Alexis, bail us out here.
You like the color red?
I do. I prefer the color red over the color green.
You're wearing
Unbelievable. Green.
That doesn't mean I can't prefer red over green. What am I supposed to do? Wear the same color shirt every day?
Yes.
Yeah.
Why?
I moved black.
Oh, no.
Right. I'm wearing a black shirt
That's
every day.
it. Why would you watch?
Now I'm going to start keeping track on it.
Like
Well, I do.
But
Any idea why we prefer
I was
using
in the
this?
same shirt. Even if I
No.
the distance between the ones that like mark the ones are like physically further apart on the cylinder.
Okay. Both of these instruments read to the ones place. Absolutely no difference there. But when you look at these two instruments side by side, we'll see how this goes. When you take a measurement with these instruments, ladies and gentlemen, what place can your measurement be to if they are reading to the ones place? Shut up, you dumb thing. I'm sorry, what place can they be to? The tenths. Okay? Now, when you are reading to the tenths place, ladies and gentlemen, again, you're estimating that last digit. And you absolutely have the right to, and you absolutely can. Okay? But if you look here, these lines that represent 61, 62, 63, 64, very close together. So when you're looking at the water level in there, it's going to be really hard to tell if it's closer to one than the other and where in between them it is. But here, ladies and gentlemen, the nice part about this one, because it's a smaller graduated cylinder, is the lines are actually a little bit further apart. So if you're debating between 21 and 22, you might be able to get a better idea of, is it 21 and a half? Is it 21.6? Is it 21.8? Again, you get to make that last digit what you want it to be, but if the marks are a little bit more spread out, it is a little bit easier for you to estimate that last place. So all things being equal, meaning they both measure in the ones place, your number is always going to be to the tenths. As long as all the objects will fit in it, I would probably select this graduated cylinder because it's a little bit easier for me to estimate. There'd be nothing wrong with you using this one. Nothing wrong with it. I would prefer using this one. So again, as Lola said, we're going to put some water in here. We're going to put the object in here. Then we're going to see how much it goes up. I mentioned to you why we have the rings on the top, right? No, I never mentioned to you why. That's why. So the rings on the top are there if you knock it over. Well, the problem is when you do this lab with especially freshmen who are, not really the greatest people in the world, okay? You know what the nice part about freshmen are? They become sophomores the next year. Now, some of them shouldn't, but they do. So we're going to take, and by the way, in the back of the room, you all have pitchers like this. You all have a container like this. These are both full of something called deionized water, ladies and gentlemen. Deionized water is water that has had certain ions that we normally find in our water removed from it. Now, in chemistry, this is important. For the lab that we're going to do, it does not matter. It does not matter that we have ions removed. But when you are doing a chemical experiment, you want to see if this chemical reacts with this one, but you have to put them both into water. The last thing you want is something that is in the water reacting with those chemicals. So we use something called deionized water, which is water that has had certain ions that we add to water removed from it. A lot of water has iron in it. This is iron removed. A lot of water has chlorine in it to clean it. This has the chlorine removed. Water that we drink out of our fountains and out of our taps has fluorine in it. Why? Because fluorine is good for your teeth, so they put it into the drinking water of most municipalities so you get better drinking water. This has had fluorine removed from it because fluorine will interfere with chemical experiments. So I tell you this, ladies and gentlemen, so you know why we have these pictures out there. But what it also means is if you pour too much water into a container like this, please don't pour it back into here. Why? This may not be as clean as this is. So please don't pour it back into there. Just dump any extra out in the sink. There are 4 large containers in the back, ladies and gentlemen, where if you ever needed to, you could fill up either one of these if they were running low, or you could hand them to me and I will do it for you. So we are going to take and we are going to put in a certain amount of liquid into here. We're going to put a certain amount of water in. Now, when I do this, ladies and gentlemen, there are 2 important things to remember. Number 1, I don't want to put too little water in. If I put too little water in, I'm about to put one of these objects in there. If I put the object in there with the water and there's not enough water in here, and the water is not covering this object, you've got to start over again. Because you have to have this completely under the water for you to find the volume of this complete object. So if when I put it in there, if this is sticking out of the water, that doesn't work for you. You have to put more water in. Number 2, you don't want to put too much water in so that your reading becomes above the 50 where you can't measure it. So if I were you, I would start out somewhere between 20 and 30, and you'll be just fine. Okay? Now, the other thing that is a little bit different about this instrument, sorry about this, ladies and gentlemen, but I'm going to draw.
Okay, Picasso. I see.
First of all, I have never been called Picasso, and I never will be. In college, they make you take a fine arts class as a general ed requirement. My fine arts class was taking drawing because I really didn't want to go dancing and I didn't really want to learn stage and theater. So I took drawing. 2.5 hours, Tuesday and Thursday night, 13 weeks drawing the same bowl of fruit. I still can't draw a bowl of fruit.
Why did you dance?
Yeah, why did you start?
There are a lot of reasons that I didn't dance. We won't even get into them. Now, anytime you have a liquid in a graduated cylinder or in a beaker or in any kind of container, if you look at the top of the liquid, you get a shape that looks something like this. This is called a meniscus. That shape is called a meniscus. And when you read a meniscus, you base it off of the lowest point. So when you're looking at it, you want to base it off of the lowest point, whatever line that is closest to. That's how you determine the volume. Yes, Jake.
Isn't meniscus also a knee?
Meniscus is a ligament in your knee. Yes. Yes.
Why did they choose the same name? It's a similar shape.
That I don't know. But why are wind and wind using the same word as well?
It's because of English.
Okay? And here's another question for you. Scent, as in smelling something, which letter is silent, the S or the C? It can't be the SC. In the word scent, like smelling something, SCENT, which letter is silent, the S or the C? So it's scent, like SENT?
Yeah.
Or is it scent, like CENT?
I don't think we can figure that out.
So the S is silent?
I think
You say it the same way that you say like scent.
Pterodactyl?
Right, but that's the same as saying sent, like I sent a letter in the mail.
From the word pterodactyl.
Can't we just have a good day?
So you're yelling at me about meniscus. Scent, scent, and scent. Spelled 3 different ways, mean 3 different words, even though they all sound the exact same. So anyway, I don't know. Can't answer. What?
It's because of the shape.
So a meniscus in your knee is shaped this way?
Something similar.
Okay, I'm good with that. Yes.
The C is silent.
In what?
Son,
How do you know?
I looked it up
How do you know that the C is silent?
because it derives from a Latin word called sentir, which is spelled SENTIR.
Yeah.
But then they added a C later on, so the C is silent.
Well, how come I can't look at it and say the S is silent?
Oh my god.
And it'd be the same as like cent, like 1 penny.
You can hear the S.
So tell me, what is another word for a penny? What?
A scent.
Cent. With the same S sound you just gave me. Okay, let's move on, ladies and gentlemen. There are some world topics that we will never solve. That's okay. We'll move on from that.
Everything is not energy.
Okay. So we read to the lowest part. By the way, the only way you can do this, ladies and gentlemen, is if you are reading this, is to bend your body down to be level with this. So you bend your body down, you're level with it, and I am at 23.8 milliliters. I now am going to take and add my object to it. Now, you have to be careful. What is this made out of? It's fragile. If you take a heavy object, hold it up here and drop it, it's going to keep going until it hits the table. Plus, if you drop an object in here, what could happen to the water inside? It could splash out. So we put this on its side, we set this in there, and we gently let it go down to the bottom. Okay? Now, we said this needs to be completely covered, right? And if you don't put in enough water, it won't be completely covered. Does everything sink in water?
No.
So what if you have an object that is floating?
You can't use this.
You can, but what do you have to do?
Use your finger.
Well, you have to use some object, some small object, to push that down below the water level. You just need to get it just below the water level because then you can find the volume. So what did I say it was before? 23.8. So now I come down here, now I take a look at it, and now I am at 38.1. The difference between the number I had before and the number I have now is the volume of that cylinder. Okay? That is called volume by displacement. Okay? Questions? All right.
So
Now, when you make this measurement, what place do you get to estimate? Tenth. Is it possible you could be off by a tenth?
Yeah.
Very much so. You're estimating it, correct?
Yeah.
All right. So, got a question for you here. I've got two objects here. Actually, I've got four. But let's take a look at the largest object and the smallest object. If I am off by a tenth in each of these measurements, let's say I'm off by 1/10, which one does it have a bigger effect on?
the small one.
The small one? Thank you, because we were doing right and left and I'm trying to think of it from your perspective. The small one or the large one?
Small.
It actually has a bigger effect on a smaller measurement. Let me quickly show you why. If we are off by 1/10, okay? Come on. Let's say that large object has a volume of 10 milliliters. 10.0 milliliters. If we are off by 0.1, how much of 10 milliliters is 0.1?
100.
100th. We are off by 1/100th of the measurement, correct? If it is only 5 milliliters and we are off by 1/10, how much are we off by?
150.
Which is a larger number, 100th or 150th?
Which one is what?
Which one is a larger number,
Oh, 150.
100th or 150th? 150th. So whenever you take a measurement, ladies and gentlemen, one thing that you should understand, and it is not your fault, you get to estimate the last place of a measurement. But when you do that with a smaller object, it will have a greater impact on your outcome. Here, not as great a difference. And I hear Jake giving a great example in the back. Jake, you want to share that with us all real quick?
So, if someone who makes $1 million versus someone who makes $100, which person would have a bigger impact if they lost $5?
Correct. So you have $1 million and you have $1,000 and you lose $5. Who does it affect more? The person with $1 million or the person who had 1,000? It affects me more. I'm the person with 1,000. Okay? If I had the $1 million, I would not be here. Okay? I would not be here. Okay? So again, that's another way of looking at it. Okay? It's the same amount that you're losing, but because the object is bigger, it doesn't have as big an impact on that. Okay? Doesn't have as big an impact on that. All right? Questions? So now you're probably sitting there going, man, this was a heck of a question of the day because we've had a discussion going for 20 minutes about density. But this also leads us to what we're going to do in any lab, which is when you're taking measurements, you need to try to be as precise as you can be, okay, so that when you're taking a measurement, there are going to be errors in them. There are going to be. You're allowed to estimate. You want to try to minimize those errors as much as possible. Okay? Questions? All right. So let's go to your EISN Let's go to, I think it's slide 16. Okay. And let's take a look at the graphing that we were starting to do yesterday, but we didn't get a chance to. All right. Huh. Accidentally deleted my whole slides. All right. So let's start with the one that says graph 1, ladies and gentlemen. Now, I asked you to open up two things. I asked you to open up the EISN, and then I asked you to also open up your graphing activity that was with the EISN that was like this, okay? Now, first of all, here's what I'm going to tell you. I got the wrong slide numbers on the bottom here. This should say slide 16, slide 17, slide 18, and slide 19, because then they will match up to the ones that are in here for 16, 17, 18, and 19. Sorry about that, ladies and gentlemen. I must have added a slide somewhere. And what? Do you have only 3 slides or 4?
Well, it's about our chemistry ESN.
Yeah.
It's about the I have all my slides on here, but on this graphic activity, I don't have that.
That's what I'm telling you. The numbers are wrong down here. This is actually slide 16, 17, 18, and 19. Just so you know. Okay, so we make a graph. In the lab that you're going to do today, I have a graph set up for you to make. All you have to do is go and put in your numbers. So I will have a data table like this already made for you, but it will be blank. You're going to add your numbers to it today or tomorrow whenever you get to it. Once you put your numbers in, ladies and gentlemen, there will be another tab that has the graph that goes with it. Okay? So, one important thing, and I think I mentioned this yesterday, don't ever, never, ever, never, ever, never, ever, ever, never, ever, ever, never, ever, ever, never, 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 don't do it. Put units with these numbers. Excel and Google Sheets cannot handle letters and numbers in the same box. So these have to be just the numbers without your units. And now you may be going, well, Mr. Brand, you told us we always have to have units with our number. And I am agreeing with that. And I have taken care of that by putting the units up here in the title. So by putting the units up here in the title, you do not have to put them with each number down below. Fair enough? Good. Questions? Wonderful. Now, I also have this set up so that the first column is what will go on the x-axis, the independent variable. The second column is what will go on the y-axis, or the dependent variable. So if you click in the box that has temperature, $, O, Celsius. By the way, one of the things I hate about Google, I can make a degree sign by making a subscript, a superscript, and the letter O. I can do it in a document. I can do it in a slide. I can't do it in sheets. So this is the only way for me, unless I want to type out the word degree, C, to make this degree Celsius sign. So label, unit. So I am now going to go up to that formula box at the top, and I'm going to highlight temperature, key, OC, by doing Control C to copy it. Now I'm going to go to slide 15, which should say slide 16, but I can't change it right now. And you can do this one of 2 ways. You can hit edit chart. Never, ever, ever. Don't ever, never, ever, don't even think about changing anything in the setup. It'll mess you up. Go to the customize. Go to chart and axis titles. From this drop-down menu here, select horizontal axis title. Highlight what is in this box. Control V to put what you just copied. And it changed it on your x-axis. Questions?
No.
I'm sorry. If you're good with this, I'm sorry. It's a little boring, I understand, because I assume that's the only reason you were doing that. Going back to your table, I now click on box B1. Go up to the top, highlight the label in the unit, copy it. Now this time, I'm going to click right onto the y-axis, just onto the title, and I'm going to copy and paste it there. I clicked right on you could go back over here to Axis Titles, Vertical Axis, or you could click right on the title to be able to edit it. Once you get it highlighted, you can edit it. By the way, I don't care if you change fonts, size, colors, things like that. You can personalize this however you wish. Okay? Last thing I have to change is the title, ladies and gentlemen. So I'm going to select chart title. What is the name of this chart? What's the name of this chart? No. We said that in science, the title is always what versus what? X-axis label versus y-axis label. Temperature versus solubility. Okay? Review of yesterday. What are the two relationships shown in this line? Give me one.
Constant.
Constant. Why?
Because it's a straight line.
Good. Is it perfectly straight?
I guess not, so I guess it's not.
Oh, hang on. You're absolutely fine. You are correct. If it is going to be a curved line, I will make it an obvious curved line for you.
Okay.
This looks fairly straight, not perfect, but that's what's going to happen with data that you collect in the lab. It may not be perfectly straight, but it looks pretty close. Okay? If not, you will definitely tell that it is a curved line. I look at this and I say that's pretty straight. So it is constant. What is the other type of relationship shown here? Direct. Why? Because it's going up. Perfect. Excellent. Wonderful. Okay? All right. Now, go into your EISN. Click on the page that says slide 16. Click on it somewhere. I'm clicking just in the middle. Insert chart from sheets down at the bottom. That was insert chart from sheets. The last thing that you were working with will be right here. Click on it twice. And now you need to find the graph that is temperature versus solubility. Highlight it and then import it. And there you go, ladies and gentlemen. It puts it into a Google document. It puts it into a slideshow this way for you. Now, really important. You'll notice it says it's a linked chart. Any idea why that's important?
You can go back. Oh,
So
so
it takes it to the.
Okay, if you're working in, say, your lab document and you can't remember where that file was, you're absolutely right. It could take you back to that file. You can hit the three dots here and you will have what is called open source, and that will open where this graph came from. Very good.
if you change any of the numbers on the table, will it change the graph?
Correct. So let's say I was making this graph, ladies and gentlemen, and when I typed in my numbers, I accidentally did this. 600.0 instead of 60. I typed in a number wrong. Now when I go to my graph here, that does not look the way the last one did, right? Okay, doesn't look the way the last one did. Now, in here, you will not notice it until you hit this update button. So normally, this is what you're looking at, and you're like, wait a minute, something doesn't look right here. You're looking at your partner. Alexis is like, how did you get a graph that looked like that? Well, I don't know, I just typed the stuff in. So now when you go back into the Google Sheet and you look at your data table and you realize Alexis is like, oh, you put in 600 instead of 60. When you change it and click on the graph, the update button will be there and it will change it for you. So that's the nice part. You don't have to delete the old one, put in a new one. You can just change things. Fair enough? You realize you typed the title wrong, you spelled something wrong, you can go back and you can change it. Yes?
Is it okay if we rename the slides so they match?
On the bottom,
Yeah.
it's your file. You can do what you want.
Okay.
Yeah, I mean, you can, yes. The only thing is you have to start with the last one
Yeah,
because you can't name two tabs. What Lola is asking is, can you correct these so this says slide 16, slide 17, slide 18, and slide 19? Yes, you absolutely can. But you have to start with this one, changing it to 19 first, because you cannot name two of these tabs on the bottom exactly the same. So if you try to change this to slide 16, it will tell you can't do it because that already exists here. Okay? If you don't worry about it if you don't want to. All right, really quick now. Go to data table number 2. Different set of data. Oh, wait. How could you almost let me forget this, Alexis? What kind of relationships again? Tell me.
constant and direct.
Constant and direct. No question looking at the graph, correct? What kind of relationship in the data table?
Constant and direct.
How do you know?
Well, if you were to like look at I mean, I kind of know because they're linked. But
Okay.
if you were to just be looking at the table, the rate of change on the y's is basically the same thing over and over again.
Really?
Or not the same thing over and over again, but the change of y and the change of x are basically the same thing.
Can you tell that just by looking at those numbers, though?
No, you have to do math.
Okay. And I'm agreeing with you. You could do the math to find that. When you do look at these numbers, what can you tell about them, though? What can you tell about temperature here?
I would say they're pretty close to each other, but not the last.
Okay, but what's happening here?
It's increasing.
Okay, increasing. What's happening here?
Increase.
So what would that tell us if both of these are going up? That it's a direct relationship, that your line is going to go up. So we can get that from this graph, or from this table, that we are going to end up with a direct relationship. What is harder is to know if this is going to give us a straight line or a curved line. Especially because, as Abby said, when you look at these numbers, they don't go up by the same amount each. So we go 20, 30, 60, 100, right? It's not like they're going 20, 40, 60, 80. Where you could then say, okay, are these going up by the same amount each? It could be done, you could figure it out, but you can't just look at this and tell. You can look at this and tell what direction your graph is going to go. Fair enough? Okay, good. So now, data table 2. What is happening to our numbers here?
Increasing.
Both?
Yeah.
Going up. What kind of graph would we expect?
Direct.
A direct. Look at the next slide. We get a direct. And now we know that it's also what? Why? It's a straight line. But that we can't tell until we get to the graph. Okay? We could tell it's direct based on the data table. We can't tell it's constant until we get here. Okay, now somebody was nice enough to leave the title in here for you because I messed up before I posted the lab. Okay, let's say I intended to do that on purpose. That way you can't say that I messed up. Okay, so we're going to go to data table 2. I'm going to click on box A1. I'm going to highlight temperature in degrees Celsius again. I'm going to copy it. I'm going to come here. I'm going to click on this label until I get it highlighted, and then I'm going to hit Control V. You want to go over here to customize, chart and axis titles, horizontal axis, go for it. Either way will work, ladies and gentlemen. More than one way of doing this. And then I'm going to hit enter so that it stays in there. I'm going to go back to my data table, click on box B1, heat and joules. I'm going to highlight that, Control C. I'm going to come back into the lab. This time I'm going to do edit chart, customize, chart and axis titles, vertical axis. Highlight what's in the box, Control V. What's that? The point is you could do it either way. I don't care if you go and you click on the title directly, you go through the edit, customize, either way, however you want to do it. Title's already there for you, so you're done with this, right? Okay. Back into your EISN. Slide 17. Click on the slide somewhere. Insert. Chart. From Sheets. Select the graphing activity again. Now, for some reason on mine, it's near the bottom here. So I got to find the right one. Temperature versus heat. And I'm going to import it. And there you go, ladies and gentlemen. Questions?
Mine is not coming up.
Okay, I will be there in a minute to help you.
Okay.
You've got 2 more graphs to finish the titles and the labels on, and then put them into your EISN on slides 18 and 19. You want to work with a partner, pull your desk together, get it done, but you've got 8 minutes to get those next 2 slides done, and if you need help from me, you call me over and I will help you. If something isn't going right, let me know.
Go down.
Important.
Okay,
It comes like this.
okay, then just first off, delete or backspace. Delete that one too. Let's try one more time.
Let me just move
What's
it.
you can go make that smaller. There you go. You can. Okay, whoa. Go back. Click that button.
I wouldn't want to drive that. Yeah.
Okay.
Yeah, I'll put another drive. Oh, she's so loud.
Bless you.
Yeah, no, she's scared. Let me for gas. Oh, but it don't go.
Now, notice your title doesn't quite fit. Don't do that. Just go back into the click on that title, and you can either justify it. Okay. Hit enter though. You get out of there when you go. Okay, now go to there and hit update.
What are you supposed to
Control
do?
Z. Control Z. Okay. So again, Control Z is a good friend too because it undoes what you accidentally did if you erase something.
I have a question about my grade. I had 100.
Especially with his spending habits.
Now I had to switch
Like, I definitely spent more money
the
than
quiz, the lab safety quiz,
quite a bit. He's right there with me.
into the quizzes category. I accidentally put it in the lab category. So what that was doing was raising that a little bit.
Oh,
Versus here, here's the thing, there wanted to be more labs that you were going to do. So again,
Wait, I can take
change some over time, but I had to get it in the lab category. Okay, sorry. When it came over from Canvas, it accidentally got put in.
I mean, my check.
It was for all 3 classes, so I had to do it. So,
Yeah. I mean, I guess I can.
yes, your failing 102 point some percent.
Well, what do you mean?
we're gonna give you 2%.
I got news for you. You better get used to disappointment.
That's what
You know why?
Mr. Grazley already had.
Well,
that.
because if you're at 100 and some percent, the only place your grade can go is down.
I know. Oh my god! When I was in 8th grade, I had over 100% in the class, and I got 100% on the final,
And it
and
went
my
down.
grade went down, and I was so mad.
As long as your grade is an A.
Here's the thing about grades. If you have 100% going, and you get whatever your average is. The only way your average can go up is to get a score higher than it. And if you've got 100 average going, you're not going up. But anytime you are below, you're gonna go down.
I have a question.
I know, but it's
I have an answer.
I'm saying,
I got reprimanded for.
does your GPA,
Uh,
so say if it's 100% A, is that any different from a 95% A?
It was
Um,
Bro.
You would have to ask the guidance counselors for sure. Normally, an A is a 4.0. An A minus is a 3.75.
No, I'm saying is 100% difference from a 95%.
No, because we don't have A pluses.
Okay.
We don't have an A plus. So until you get down to the point where it's an A minus, anything in A or an A plus, anything in A is a 4.0. Some schools you have to have an A plus for a 4.0. An A would be like 3.67 and an A minus would be like a 3.33.
That makes me mad.
I have a question.
I
I
would
would
like
like
that. I would not like that score. That would
you know when the announcement came on and
I
then
think
like,
A plus.
the manager told the staff the needs to go to room 110. Are you on that? So you look like you'd be on that.
So you just gonna do
No,
drawing
I'm
like
CPR certified.
That nigga's not gonna go.
I'm not.
If he doesn't go there,
I'm
he's not gonna.
CPR
Same thing as last year. He's gonna
I,
go
where did my
Wow.
access go?
But not for a dog.
It is still there.
I told him
Go to customize chart and axis
Right.
titles, select vertical
That's pretty
axis.
slow. Go first.
No, up here.
Oh,
There,
okay.
titles,
The third.
do vertical axis.
I got
Because
my
you have
big
nothing in
like-
there, just took it away.
You not know anything.
So what might have happened is you might have been going to type something in there and deleted it.
Why go this
Now
way?
you have to go that way.
I know.
Yes.
I can't see what
I was doing the last one.
don't.
Yeah.
I'm actually, which one is up? The first one is.
Okay,
Okay, so.
Will we have time to do this? Well,
Yeah.
Okay, so. Yeah.
Oh yeah, that nigga was like, my brother got the car.
Question.
You can walk here.
Right.
That was 2 bucks.
It's for the
I
draw.
was gonna beg him to come, but I offered to taste it. I was gonna beg him to come. I was like,
Actually,
I.
we're gonna manifest getting a.
so here's my favorite
Look
thing.
like they can.
Because I can go around and say happy
Because
shit
math
day.
always kills my GPA.
Or I can just go around saying shit because
Oh,
it's so happy it's Thursday.
slideshow.
Oh, shit.
Click on that.
That's my favorite
Slide.
thing.
What?
Slide.
You know what? Stop
Oh, this
being
one
such a
is-
hater.
Listen,
I know. Oh,
In
so I
search.
you
Literally
literally
swear
spent
in my house.
I was in
Charlie,
Spanish for like,
say this.
oh, that happened
Yes.
yesterday.
I was in Spanish for like
Literally
literally 5 days, not 5.
From sheet.
5 days. Yeah,
You
you
guys
guys talked about your house.
We did.
Because I was in Spanish,
But like,
Thank you.
our ideas are probably gonna get vetoed by people who like
Insert.
weren't even
Sure.
there.
3.
Yeah.
Or
Out of the
4.
people that showed up,
That's
3 of us
solubility.
aren't even gonna be on the float because
Yes.
we're in vain.
Yeah, that's
That's okay.
Now, you still have.
But now our house has tons of snacks because I was prepared for like
we didn't eat any snacks.
I know so no one restaurant but I
Yeah,
didn't
that's so crazy.
So like
I didn't. You never said you were gonna have pizza, so why didn't I?
I love We're like how prepared for like 70 people.
Right.
You know, like
Four slide is there.
it's okay. I'm not salty at all.
You are.
Not at all. Just kidding.
Well, my sister was happened. I was there, and then she was laughing at me.
She was laughing at
You
your
can if you
stories
want
or
No, she's laughing when I told her that.
oh yeah. Man,
I don't know.
Wait.
She said her mom told her not to break up.
No, now she
Wait, so stuff is her to ask.
Yeah. Wait, and now she's dating
From that
that
spreadsheet.
other girl. Yeah, basically.
Wait, who is that?
I don't know.
Right now, there are 2 people.
I've never seen this.
Wait, which one is Glenn?
I don't know.
Okay.
Like, there are like 3 guys that know her.
No, there's a lot more than 3.
Yes, well, she's beautiful.
At this point, you also just gotta let him make his own decision.
But yeah, like her boyfriend's like her boyfriend was the
Hurry, because we're gonna start working on the lab.
Okay, I'm gonna hurry.
and has like been like posting like songs on his Instagram notes that are like dating her. Like she knows it's like about her, you know. I know, and she was like, my mom's telling me like.
All right, open up your
That's exactly.
graphing to find density lab from the Canvas.
I feel bad because I don't feel bad. That's what she
In the
said.
module in Canvas, there is a assignment titled Graphing to Find Density. Open it up.
I love her. She's so funny.
We have already explained to you how to find density. We have already shown you the method that you are going to use to find volume. We have already talked about how you are going to take this object and put it on a balance to find the mass. You are going to end up finding density two ways in this lab, ladies and gentlemen. So let's talk about that. So when you open it up, it is the Graphing to Find Density lab, and it looks like this. 27 points on this lab. If you do not turn it in on time, which means you are here today, you are here tomorrow, you don't turn it in by the end of the day tomorrow, the best you can get on it is a C. Turn it in by the end of the day tomorrow, you can get an A or a B. You could get an A or a B. Doesn't mean you might not still get a C, but you have a chance of getting an A or a B. Yes, Lola.
When you say end of day tomorrow.
That means before it turns to Saturday, September 21st.
Okay, some people are like.
Nope, that's what I mean by end of the day, meaning the end of the actual day, not the school day, the end of the actual day. Okay? Density is found by taking an object's mass, dividing it by its volume. In this lab, you will find the density of a series of objects, meaning all four of these objects, ladies and gentlemen, are the exact same material. They are four different sizes. They are two different shapes in this set, but they are all the same material. Therefore, they will all have the same density. Two ways. Then you will use the information to compare the known value of the object. You are going to find what the density of these objects are. You're going to get a number. Then I'm going to tell you what your target was. Then I'm going to tell you what you should have gotten. And we are actually going to do a calculation to see how well you collected your information. How close you were to what you should have gotten. Okay? So, by the way, how close you were to what you should have gotten, what are we talking about measuring?
Accuracy.
Accuracy. Precision comes from each individual measurement. Accuracy will come from how close you are to what you should have gotten. So if you look, ladies and gentlemen, what was our definition of an experiment?
A carefully controlled series of
Observations. So you'll notice, carefully controlled series, observations. Here's the steps you do. Here's where you write down what you see. When you get to a station, ladies and gentlemen, the first thing that you are going to do is you are going to look at your samples and you are going to write down in this box what color they were. Because when you know what color they are, now you can go to the very last page of the lab. At the door, hang on just 1 second. And here is a list of what the known values are. So when you get to your station and you have the tan wood-colored sample, your density was supposed to be 0.77 grams per milliliter. If you get to the station and you have a purple or a gray color, it is supposed to be 1.37. Now, can someone tell me what the difference between red opaque and red translucent is?
Translucent, you can see through.
Close.
Kind of ish.
Translucent, light can pass through
That's
it.
what I meant.
I understand. Opaque means what?
Like cannot pass through it.
Light cannot pass through it. So, glass is transparent. You can see through it. The lights above our heads have a translucent cover on them, which means light can come through, but we can't see through it. Kind of like a stained glass window in a church. And then opaque would be the ceiling tiles, which light cannot go through. A wall, light cannot go through. If you are unsure of which of these you have when you get to a station, call me over and I will help you know which one to write down. At each station, there are 4 objects that are in a container like this. Open it up and take them out. These are the 4 objects that you are going to be working with. Now, they may all 4 be cylinders, or one of them may be a rectangle, or a rectangular shape. We'll leave it at that. Okay? Trying to think of 3 dimensions for a rectangle.
Rectangular prism.
Okay.
A triangle.
Well, no, it's not a triangle. It's a rectangle. I can't say cube. A cube is 3-dimensional because it's not all 4 sides the same, but I'm trying to think of it. Anyway. Okay. So back at the top, the first thing you need to do is at least make 3 qualitative observations. Qualitative means no numbers. What you see, what you feel, what you smell, what you don't taste it. Don't taste it. And if it is speaking to you, let me know and I will get you the help that you need. Okay? So rely on sight, feel, and smell. By the way, one of the things that people always ask me, what if it has an odor but I can't describe it? You simply put down that it has a noticeable odor. That is fine. Okay? Either one. You could just put down that it has an odor. Okay? Alright. After you make your observations, then you're going to start collecting your data. You're not going to get this done today. You will have time tomorrow to finish it up. Down at the bottom here is where you collect your data. Now, I did it one way. I could have done it another. Don't yell at me by the way I did it. Largest, smallest. Second largest, third largest. Okay? I could have, instead of third largest, called it the second smallest. I don't know why I went with third largest. I guess I was in a larger mood that day. Second largest. Okay? So, that's those 4. You got to do them in the order that they are here. Here's a spot for you to write down how much water was in your cylinder. Here's a spot for you to write down how much water was in the cylinder or the level of the water what the cylinder had for a level when there was water and the cylinder in it. By the way, cylinder, I'm talking about this inside this cylinder. Subtract the 2 to get how much the volume of the cylinder was. Not the graduated, the cylinders that we are using here. And then mass, put it on the balance. Find the mass. By the way, do not put any what in here. Why? They're already up here for you. You don't have to worry about it. Questions? Go. Yes, everybody should work with a partner. Find a partner, get to work. Oh, freeze. When you are done, please put these back in the container. Put the cap on them so they're there for the next group, and make sure you empty out any water that is left in your cylinders.
So can I reprint a copy of this tomorrow? Because my computer's about to die. So I'll just copy your pictures tomorrow.
Are we, Mr. Brennan, are we saying the color of the container or
The objects inside. Do not describe the plastic clear container that they come in. Describe the objects inside.
I'm too smart.
What's that? That's fine. Okay, I don't want you to be alone. Okay. I did take attendance, that's good.
They have a weird older Disney.
Again, you can use whichever one you wish. Not a problem. By the way, when you are putting water into the graduated cylinders, it is best to start with the pitcher, and then if you want to get to a certain amount, you can use the water bottles. If you try to fill out of the water bottles right away, it'll take you a long time to get 25 to 30 milliliters in there.
Well, are they what you see?
Yeah.
Are they what you hear?
Like a cylinder of air.
If you're describing shit, yes. Oh, so you're just listening. It's fine that you guys kind of work together. It's fine. Make sure you're doing it. Hey, you guys. So again, you have similar shape. Please don't write down their color. Write down your own.
One is big and one is small.
Oh, there's 4 objects. What are the 4 objects have in common that you can describe? Okay, well, first of all, don't do white cylinder as one line. White and cylinder are 2 different observations. What do you mean, what is it?
Wait.
This is not.
Wait. Can I say that the bigger one has more mass?
No, that is.
Oh, that's not.
You're gonna do things that you can describe about all 4. What? Why are you confused?
What can you describe about all 4?
Have you described what you smell? Have you described what you see? Have you described what you feel? If you do one of each of those, you've got 3 observations, which is all you need for all 4.
It feels like, yeah.
How does okay, how does oil? Okay, how does sand how does this skin cut?
It feels like,
You just give me a Mr. Grant. Again, I would do probably about 25 to 30 because those will be fine. If you do less, it might not be enough.
okay,
Mr. Brando.
Yes.
Can we pour this water back?
No. When you're done with your water, it goes down the sink. Just make sure you catch your block before it goes down my drain. Yes.
Absolutely. Well, it's up there, but you need to include it down below after you take out your headset. Yes. Once you put it there to stop. So then when you put the cylinder in, it's gonna go up.
what's the other one?
You tell me what that is. And then you take and you subtract these 2. That will give you the volume of just the cylinder. That option. Just that up. Okay. By the way, to fill that, you may want to use the picture. Wendy.
I'm sorry.
Okay. Don't put it out. Go 25 point something, 30 point something. Now your other measurement.
No, we put it in.
The way you find this yellow color, this number, minus that.
How was your water before?
Mr. So we take the max first, right? Do the math.
I don't care what already did.
Well, no, I'm just giving you like, okay. And then combine the volume, then we
But you have to have water in there first to know what the volume of the water is. So that first column, that white one up there, how much water is in there? No, every measurement should be to the tenths.
Yeah, that's for volume.
That doesn't work. Put it on the ground, on the table, and bend yourself down.
30.
Okay, so write that down. Now, when you put the object in there, it's gonna go up. You again, find the volume of it with the cylinder in there. Then you subtract the two for that yellow column.
By the way, ask yourself this. Look at your measurements if you've made a volume. What place should your volumes be to? The tenths. If your volumes are not to the tenths, you're not using the precision of the instrument.
No. You have this thing high balance, you will find the mass of some object. I did, and you're gonna see, when I told you that to find the mass of an object, you need to use a balance. Like you did in the precision lab when we had the three balances sitting out. Why are you dropping sig figs? In this, all of them, and that it's tense. Don't drop sig figs. Good night, stay right there, please. Stay right there, please. Over this way, over this way, over this way. Now run real fast. You didn't do what I asked you to do. You're running real fast. I need to say stop. Have you never seen the movie Die Hard? The terrorist attack when he's got his shoes off, he doesn't get to put them back on. Your shoes do not affect how much you can.
By the way, you have 90 seconds left to class. So you can stop what you're doing now, put all of your samples back in their container, dump any water that is in cylinders, leave your cylinders sitting there, and tomorrow we will continue. The only important thing is that tomorrow you go back to the same place and work with the same substances you were working with today. So I hope you know what color they were.
Yes, and then proceeded to.
Are you trying to die a slow and painful death?
Oh, your necklace is nice. I like it.
Thank you.
Like a pennant.
It's a basketball going through a hoop. Goodbye, ladies and gentlemen. We'll see you tomorrow. Have a great day. Adios, arrivederci. Get out.
Oh yeah.
Go. Get.
I will come back then.
Oh. Hey. Get out. Get out.
We're trying.
There's a difference between trying and doing. I don't want you to try. I want you to do.
Yoda.
We'll do both.
The door swings all the way open. My goodness. People. People. How are you, Jamari? Good. Good. You okay? You're awfully quiet.
No, because it doesn't say that anything has. Like, does it say that you said? So then you're probably just using.
Yes.
Something for me.
For me,
Yes, can I
it's
sign
what
it?
I've always. Oh, you want me to sign it?
Can I really have your autograph?
I want chips so bad.
There you go. Thank you. You're way too young for chips.
Chips?
Yeah. You have no idea even who played in Chips.
What?
Chips
What are
was
you
a,
talking about?
no, not the game.
Gambling?
Chips was a TV show back
Oh,
in
that
the
one.
80s, maybe 90s.
That's a good job.
California Highway Patrol.
You're a weirdo. It's a
Thank
good
you for
job.
noticing. Sorry, you've been in class before. How? I was weirdo then.
Yeah,
Why do you seem shocked by it now?
because you're even more of a weirdo now.
I understand. Well, I have improved my game over time.
Bruh.
Hello.
What if they change theirs?
Wait, actually no, because maybe I'll get 2 out of 10 points for it, and then I'll still get 25 out of 10.
Relax, down in it. Like, okay, he's not even sweating.
They're gonna see you at the meet and then they're gonna find out. He doesn't have any living.